Now we're going to get into evaluating limits once more, but in this case we're going to take a look at some rational functions. Now here's some important things to note when we're talking about limits. The first thing is that if f of x is a polynomial, simply evaluate f at a. So that's where we're going to plug in. If f of x is not a polynomial, such as a rational expression, and you'll see that, a rational expression in the two examples below, try to evaluate f of a, unless it gives some indeterminate form, such as you end up dividing by 0, you have something undefined, or you have an infinity divided by infinity case. Alright? In these cases, try to algebraically eliminate the difficulty before substituting in the a value. So let's go ahead and take a look at the two examples and try to see if we can figure this out. So in the first example, what we're going to do is try to plug in 3 and see if we have any issues there. Well, let's see. 3 over 3 plus 2. Well, obviously 3 plus 2 is not going to give us 0. So this one right here is actually going to be pretty easy, and you can confidently state your answer as 3 over 5. Because what happens here is there's nothing out of the ordinary. We're not dividing by 0, there's nothing that's undefined. So our answer is simply 3/5. Okay, so that was fairly easy. Let's go ahead and take a look at the next one. Let's go ahead and just start off by plugging in that 3, the limit as x approaches 3. So we'll plug in 3 into just our denominator. Now notice what happens. In that case, you'd have 3 minus 3, which equals 0. So you'd have some polynomial function divided by 0. Well, we know that we cannot divide by 0. That is a no-no. So what we need to do is we need to see if we can't use algebra in order to simplify this. So we're going to suppose factor. And let's take a look at the top there. So if I were to factor that, now there's various methods you can use, so you'll have to go back and look for methods for factoring. But suppose I were to factor that. Well, that is going to give me the limit as x approaches 3, and factoring this on the top, it actually factors really nicely. X minus 3 times x plus 5 over x minus 3. So when I factor this on the top, it's actually these two factors down here below. So I want you to notice something that happens. In this case, what ends up happening is that we can line out, and I say line out because we're left with a factor of 1. We can line out our two factors, x minus 3. Okay? Because of the fact that we have one on top and one on bottom. And when we cross them out, we're left with a factor of 1. So we can actually rewrite this limit here. And it's really simple. We can write the limit as x approaches 3 of x plus 5. And in this case, it would actually be really easy to plug in now, because now we're dealing with just a straight polynomial function. So this one becomes really nice at the end, because all that we have left is plugging in that 3 plus 5 equals 8. Now, we weren't able to evaluate the limit initially because of the fact that we'd end up dividing by 0, but now that we've eliminated some factors, we have a really nice limit that we can figure out, and the limit here happens to be 8. So these are two different examples of rational expressions and how we might be able to use algebra to help simplify.
Made with Doodlecast Pro.